Welcome back. We're continuing to look at solving rational equations and inequalities. In this video, we are looking at another example of solving equations. This problem, the equation we're solving here is 2x over x plus 5 minus x squared minus x minus 10 over x squared plus 8x plus 15 is equal to 3 over x plus 3. So when we're solving this equation, we want to make sure that we keep in mind that we're finding values that will make statements true. First thing we want to look at is finding our domain restrictions. And our domain restrictions are those values which make my denominator equal to 0. Unfortunately, this problem isn't quite ready to do that because I don't know what values will make this expression equal to 0. So a good first step for every problem is going to be to fully factor. Fully factor at least the denominator. All right, 2x over x plus 5 is factored, so I don't need to worry about that. X squared minus x minus 10 actually doesn't factor, so I am just going to leave that as is. And this denominator here will factor to be x plus 5 times x plus 3 is equal to 3 over x plus 3. So now if I look at my domain restrictions, from my first piece, negative 5 will make the denominator equal to 0. My second piece, negative 5 and negative 3. My last, negative 3. So I have my domain restrictions. X cannot be equal to negative 5 or negative 3. I now need to find my common denominator or my least common denominator. So my least common denominator, looking at my first term, I need a factor of x plus 5. My second denominator has x plus 5, but it also has x plus 3. And my last denominator is just x plus 3, and that factor is already there. So I'm going to take the least common denominator, and I am going to multiply both sides by x plus 5 times x plus 3. Really, I'm multiplying every single term by the least common denominator. So that's going to make my first term 2x times x plus 5 times x plus 3 over x plus 5 minus x squared minus x minus 10 times x plus 5 times x plus 3 all over x plus 5 times x plus 3 is equal to 3 times x plus 5 times x plus 3 over x plus 3. At this point, I can cancel out common factors to simplify. So I see that there's an x plus 5 in both the numerator and denominator there. There's an x plus 5 and an x plus 3 that I can cancel out, and I've got an x plus 3 to cancel out here. So now this just becomes a simple quadratic equation that I have to solve. So I'm going to need to do all of my multiplication, addition, get all of my terms on one side. So this gives me 2x squared plus 6x minus x squared plus x plus 10 is equal to 3x plus 15. Simplifying x squared plus 7x plus 10 is equal to 3x plus 15. X squared plus 4x minus 5 is equal to 0. That will give me x plus 5 times x minus 1 equals 0. So I've got x equals negative 5 or x equals 1. Before I go any further, I already see that this is a domain restriction. I see that from up here, from my domain restrictions. So I'm not even going to bother plugging this in. I know it's going to make my denominator 0, so this value is no good. I am going to take 1, and I'm going to check 1 in my original problem. So that'll give me 2 times 1 over 5 plus 1, which is 6, minus 1 squared minus 1 minus 10 over 1 squared plus 8 times 1 plus 15 is equal to 3 over 1 plus 3. So 2/6 is going to be 1/3 minus 1 minus 1 minus 10 is negative 10. 9 plus 15 is 24. So I've got 1/3 plus 5/12 is equal to 3/4. I'm going to change everything here into fourths. So this is going to be, or into twelfths. 4/12 plus 5/12 is equal to 9/12, where 9/12 is equal to 9/12. So I did that by multiplying this term by a convenient value of 1 and this term by a convenient value of 1 to get my common denominator. 9/12 equals 9/12, so x is equal to 1 is my solution to this problem. X equals 1 is the only value that will make a true statement. -5 seemed like it would, but it's extraneous because it actually makes the denominator equal to 0, which gives me nonsensical information.